Hello everyone. We are students from Vishwakarma Institute of Technology, Pune, and this is our assignment for our subject Computer Organization and Architecture, and our topic is Boots algorithm. We are from Division Q, Batch 1 and Group 2. The members of the group are as follows: Roll number 7, Siddharth Sadke; Roll number 8, Aditi Sadavare; Roll number 9, Prince Sahani; Roll number 10, Pranav Sahasrabuddhe; Roll number 11, Sahil Kumar; and Roll number 12, Dilpreet Sahani.
So, Booth multiplication algorithm. Booth multiplication algorithm is a multiplication algorithm that multiplies two signed binary number in two complements notation. It works on the string bit 0. No additional bit is required, only shift the rightmost string bits and a string of ones in the multiplier. So, the uses of Booth algorithm. First, high-speed multiplication in computer processors. Second, it is used for simulation and development of digital multiplier. Third, design of digital filter and signal processing algorithm. Fourth, calculation of matrix operations in computer graphics. Fifth, implementation of polynomial evaluation and other mathematical operations.
So now, let us look into the Boots algorithm using a flowchart. So the flowchart says that first we have to start the process. Then we have to assign A as an accumulator equal to 0. Q minus 1 is already given as 0. M is the multiplicand, Q is the multiplier, and count N. Okay. So the next process says that we have to see the least significant digit of the multiplicand, that is q0 and q minus 1. If it is 10, then we have to perform the operation a equal to a minus a, and if it is equal to 01, then the operation is a equal to a plus a. Any other ways, if q0 and q minus 1 are equal to 1 1 or 0 0, then the operation which we need to perform is directly the arithmetic shift operation, that is right shift all the digits and just reduce the count equal to count minus 2. Or else if the cycle goes to 10 or 01, then too we have to perform first these operations, that is a equal to a minus m and a equal to a plus m. Then only we can perform the operations of arithmetic shift right and count. If the count equal to 0, then yes, we have to end the process, and if it's not equal to 0, then we have to start again over here and repeat the process several times. So now let us try to understand the Boots algorithm using an example. So we have taken here an example of 8 into 9. This is the binary representation of 8, and this one is binary representation of 9. All the values we have assigned as per the flowchart. So multiplier we have assigned it as 1001, which is the value of 9. Q minus 1 as 0. Accumulator as 0. Initial, these are the initial values, and in this last column we are going to perform the operations. So now, from the least significant digit of multiplier and q minus 1, we can see that the digits are ending in 10. So if we see go back again to the flow chart, we can see that if the digits are 10, then we have to perform the operation a equal to a minus m. So the same operation is performed over here, and the result is printed into the next line. Again, if we have performed this operation, then the next step is to perform the arithmetic shift right. So we have shifted the digits, that is 1 in this row, 0 in this row, and so on so on. We have printed the third line. So now we have to reduce the count by 1, and the count becomes 3. So now when the count becomes 3, again the values we can see over here. Again we have to see the ending digits, that is of q and q minus 1. It says that 0 and 1. If it's 0 and 1, then we have to perform again the operation, that is a equal to a plus m. So after performing this operation, we get the result printed into this line. Now we have to arithmetic shift right those digits, and after shifting those digits, the result is printed into this next line. Okay, so now we have performed till now fourth and third count. Now we'll move to the second count. So into the second count, we can see that the digits are ending with 0 and 0, and I have said that if the digits are ending in 1 1 or 0 0, we have to perform directly the arithmetic shift operation. So I will be performing arithmetic shift operation directly, and so result is printed into the next line. Okay, so Again we have to see the ending digits. The ending digits are 1 and 0. So if we again go according to the flow chart, then we have to perform the arithmetic operation, that is a equal to a minus a. So the operation is performed, and which is printed into this another line. So again the next step is to arithmetic shift right as digits. Arithmetic shift right is again printed into the next line. So now the count becomes 1. So now the next step is the next step is to add a equal to a minus m. So the next operation is performed into this line. Again, if we see the digits are 0 and 1, and so we have performed the arithmetic shift right operation into the last line, and the answer that we get into the combining the whole accumulator column and the multiplier column, that is 1001000, that is the answer for this answer, that is 8 into 9. So the 8 into 9, the answer that we get is 72, and which is printed into this last line of the flowchart or the table, which is the binary representation of 72.
So, conclusion. First, Booth algorithm is a highly efficient method for binary multiplication in computer processors. Second, it is widely used due to its effectiveness and is a vital component of modern computer architecture. And the last point is the algorithm breaks down operands into smaller binary representations and performs arithmetic operations to produce the final product, allowing for efficient computation and data processing. So, so guys, if you like the video, please like, share and subscribe. Math का